Hey everyone, welcome back to my channel. Let's solve some LeetCode today. In this video, we are going to solve this specific problem, intersection of two arrays. Initially, I was going to skip this video, skip making a video for this problem and just going to solve this problem in this way, but it's not going to work, so let's solve them together. Given two integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays. And you may return the result in any order. So the problem with this solution is we have intersection method for sets only. So sets can only contain distinct elements. So they cannot have duplicates, and they support intersection method by default. But lists are not the same, so intersection is not going to work in the same way as sets. So we are going to solve this question manually. So one possible solution that's coming to my mind is using counters. So our first approach, using counters for nums1 and nums2, and taking minimum frequencies. Is that gonna work? So yes, it's going to work. For example, like in this first example, we have two ones, two twos, and we have two twos in nums2. So we are going to compare the frequencies. So we have and take the minimum. So we have 2 1 in here, but 0 in here. So we are going to add 0 ones to our output, and we have two twos in here and double twos in here. So the minimum is 2 times 2. So the output looks like this. So the time complexity of the solution is O of n, or let's say plus k, for n stands for the length of nums1, k stands for the length of nums2, but anyways, it's O of n time. We are passing each array exactly one time. So the space complexity here is O of n as well, because we are using additional space, counter dictionary. Can we do this better? Do we have better approach? I think this is the best approach that we can come up with. Or let's give it a try with sorting. So sorting, can we do in constant time? So by trading of the time complexity, sorting plus 2 pointers. So the time complexity of this solution would be of n log n, and space complexity would be of 1 if we are allowed to modify the input arrays in place. So how are we going to do this? So we would have, after sorting, we would have an array looks like this, and the second array would look like this, and we could have a pointer for both arrays, and if then we could compare the elements of each pointer in both arrays and just move it forward until we have something equal. Or let's say here we have 3 and here we have 3 as well after 2. So our both pointers begin their journey at index 0. So we compare these two elements and we can see we can increment the pointer that has smaller number on it and compare again. So we still have small number, and we have equal numbers, so we add them to our output. So let's add them and increment both pointers. So now we have one more equal numbers. So let's move the pointers one more time and compare them. Increment the one that has small number, then we have equal element, then we will add this element to our output array. So this would look like this. So if we can trade off the time complexity and we need optimal solution optimized for space, then the second approach is better. It's more optimal considering the space. It's using constant space, no extra space. So but if we want more like optimized solution for performance, then the first one would be great choice. But it would look like this, simple. So let's code the first solution. Let's use counter one. So this we are going to leverage counter class here, and counter 2, counter nums 2. So this will give us a dictionary, and let's initialize our results list and return that result in the end. And in the beginning we are going to iterate through counters. So for simplicity, let's iterate through in counter 1, so character and frequency as value, and counter 1 dot items. If character in counter 2, then we are going to add it to results. But how many times? So it depends. Result will append a list, concatenate a list to result, because we might have multiple elements here. So it's not character, it's number actually, none. And we have num multiplied by minimum of frequency and counter 2's num. So if it's num, then we are going to have empty list, and it doesn't add anything, any number to our result. So this solution is going to work. Let me just take a look at for the syntax errors. So let's remove this line and let's run this first example. So we have this counter here that would look like this. Counter 1, so 1 is occurred 2 times, 2 has occurred 2 times, counter 2 has occurred 2 times. So we are iterating through counter 1 and 1. So in the first iteration, nums is 1, frequency is 2, but it's not in the counter 2. And the second iteration, it is 2 and frequency is 2. So this condition will be hit. So enter it, and the counter 2 num returns us the equal value as frequency 2, minimum of 2, and we add 2 numbers. So in this case, num is equal to 2 to result and return. So I'm ready to submit this solution and hope it works. I haven't missed any edge cases here. So yeah, as expected, it's working. So we have some follow-ups here. What if the given array is already sorted? How would you optimize your algorithm? So we would optimize it in this way using 2 pointers. So we wouldn't use extra space if they were sorted. What if nums 1 size is small compared to nums 2 size? Which algorithm is better? So if it's more than iterating through the nums 1, in the case both of them are sorted or not? If yes, then we could just know like whether the nums 1 is small or nums 2 small, this sorting and 2 pointers solution would work in the same way. Maybe it's not sorted. How can we leverage this? Nums 1 size is small compared to nums 2. So let me open my terminal really quickly and move it to here. So where are you? Okay, let's open Python 3, and nums 1 is smaller than, let's say, 1, 2, 2, 1. Or let's say this is nums 2, and nums 1 is equal to 2 and 2. Nums 2 and nums 1 returns something like this, but nums 1 and nums 2 returns something like this. So basically we could just have an array with smaller size on the right and could get the solution here. So let's give it a try. If length of nums 1 is less than length of nums 2, then return. So an array with smaller size should be on the right, so nums 2 and nums 1. So in else we are going to return nums 1 and nums 2 and get rid of this code. So let's submit this solution. It doesn't work, so this approach is not going to work. But why? So let's take a look. Oh, it's always going to take all numbers that's coming on the right, so because of that it's not going to work. What if the elements of nums 2 are stored on disk and memory is limited such that you cannot load all elements into the memory at once. So we can do partitioning here. So we could read partitions until no more partitions are left, then build our solutions in that way. So that's it from my side. Thanks for watching. See you in the next videos. Bye bye.